Good morning, everyone. I hope can you guys hear me? Can anyone hear me?
Yep.
Okay,
Yes.
thank you. Welcome to the first exercise session of this course. Uh, we'll be we'll be conducting this session on every Monday from 10 to 12 in the span of about 2 months until 19th of May. And all the sessions will be conducted over Zoom. So you don't need to go to the classrooms. You can join wherever you are. And we'll be discussing all 7 exercise tasks that are already posted on the Elan page. If you haven't joined the Elan page, um please do. And you can already see all the 7 exercises. Um, and in the session, so you can finish them wherever whenever you want. And during the sessions, we'll be discussing all the exercise tasks. Also for we'll be giving weekly tips about how to solve the exercises. And I'll upload this file to the Elan page as well, so you can check out the tips for doing the exercises. So the topics we'll be covering for this course. Um, for this session, we're doing a brief introduction of the how exercise session works, and we'll recommend a platform for you to do the task. And for the topics, we'll cover anomaly detection, fuzzy logic, clustering, different clustering methods, k-means, fuzzy c-means. All all these topics are topics that will be discussed in the lecture, and then the exercises are related to the topics that are taught in the lecture, and also predictions, different prediction methods. And for the last exercise, we'll do a classification task on the gene expression data. So the logic is that you learn something from the lecture, you learn these topics from the lecture, then based on these topics, we'll we'll do an exercise on this topic. The timeline for the exercises is that you can arrange the time on your own. This course is very flexible. Starting this semester, we're also recording the session. So even if you cannot join the online meeting, you can watch the videos later. Um, for the You can submit your work to the Elan page. The deadline for all of the exercises are 22nd of May. So as long as you submit before the deadline, then everything's good. And also, if you want to submit earlier weekly, that's also okay. Your exercises will be graded earlier. But all in all, you have about 2 months time. You have about 2 months time to finish all 7 exercises. And if you can solve those exercise tasks on your own, you don't even need to participate this session. We don't have any attendance check. So as long as you can finish the exercise, then it's okay. Also, like we have mentioned before, The exercise gives you a total of 20 points towards your final grade. So each weekly exercise is about 3 points. Also, you can see my email address here. If you have any questions during the session or after the session, you can just turn on your mic and ask your questions, or you can leave them in the chat window, or you can email me. So the platform we're suggesting for you to use is Google Colab. It's a very it's a very easy online platform, and they provide the resources for you to run the code. Um, I think I don't know if you are familiar with it. For people those who aren't familiar with it, we'll give a very quick and simple introduction. There are a few advantages of using Google Colab because everything is done in the browser. You don't need to install anything. You just open this link and then it can start your coding task. You can start your coding task there. And they offer you don't need to configure anything. You don't need to set up any environment. And they give you free access to GPUs and CPUs and TPUs. And you can also afterwards you can just export it into a Jupyter notebook format, or you can just share a link to your code. If you are doing something that's more resource intensive, they provide you with free GPUs to speed up the processing. And here's how to I will show you on the on the web page. Okay, so this is what you see when you open the Colab when you open Google Colab in your browser, and you can just create a new notebook, and then you can start your coding tasks here. If you're doing something that's more resource intensive, for example, for deep learning tasks, for image classification tasks, you can accelerate the processing by changing it to a T4 GPU, but only use it if you actually need the resources. Because for our course, most yeah, even your own computer can handle most of the processing that's required for this course. And if you need any libraries that are not in Google Colab, you can use the command exclamation point pip install. Then you just put any packages that you want to use. For example, let's connect to a server first. For example, if you want to use this package called BirdTopic, um, then you just run this command in the cell. Then it will start installing all the packages that you need. Okay, we've covered how to enable GPUs and import third-party libraries. Then we can, yeah, after this, you can just start your coding tasks. For our course, for me personally, I'll use I'll be using VS Code. You can just choose whatever you're comfortable with. Um, Here are some tips for the first exercise. Let's let's take a look at the exercise questions. Today we have some simple tasks. It's mostly visualization. And here we have a negative selection algorithm that we will implement. Okay, let's take a look at the exercise questions. The warming up task with Python and MATLAB. First, here are some steps that tells you how to solve the exercises. So it tells you to load the data from bogus student data. Okay, then we take a look at the data. So we see we have three columns, exercise points, exam points, and grades. And here are the respecting values for the exercise points, and exam points, and grades. So for grade, we can see it ranges from 0, the lowest one is 0, and the highest one is 5. The task is to load and visualize the distribution of final grades. Visualize the connection between exercise points and the points in the exam. So we visualize connection between those two. And what conclusion can you draw from the plots? Use matplotlib if you are using Python. And this is a visualization package. Let's take a look. So if you're using Python, this will be a very useful package for you, and we'll be using this for most of our visualization. And if you just search matplotlib in Google, and you can go to their website and check out their documentation, and you can see all the types of plots that you can make with this package. For example, if you want to do a bar chart, or if you want to do a stack plot, or histogram, box plot, or something more fancy like a 3D plot to visualize data. You can just click on whatever plot you wanna use, and then you can see the documentation for it. Here's an example code for uh, how to plot data with this plot. So back to our exercises. The package will be using our NumPy and matplotlib. Okay, first we load the bogus student data. The name of the file is bogus student data. And we change the delimiter to a space because here it's space separated. It's not comma separated. So we change it to a space. Then we store the grades data in the variable grades. And we do the same for the other columns. Now we want to visualize the distribution of grades. Um, the connection between grades and so we want to see the connection between exercise points and the exam points. Okay, first we visualize grade, and for this we can use a histogram. So we simply just create a plot and we use histogram. By the way, if you're watching, it's best to follow along while we're coding. But if you cannot, you can also do it on your own later because this session will be recorded. And we we plot the grades in a histogram and we set because the grade ranges from 0 to 5, we arrange 6 bins for it. So it doesn't go all over the place. And we start from, because we need to start from 0, so we put minus 0.5 here to 6, and the steps is 1. So it goes up, the value goes up from 0 to 5 by a step of 1. So they're all integer values. And we give it a title. We call it distribution upgrades. And then we can show the plot. And yeah, we can see we have people, so people, we can see grade 4 has the highest number. So most people got grade 4 and 3 and 2. Less people got 5, 1, and 0. And to continue, we want to visualize the connection between exercise points and exam points. And a good plot for this will be a scatter plot. So we have two axes. One axis will be the exercise points, and another axis will be the exam points. So, and the dot will show us how they are distributed. So here we create another plot and we use scatter. And we'll also give it a title. Maybe you can also set the label for X and Y. Okay, here we can see the connection between the two. So what conclusions could you draw from these plots? Um, People who got lower exercise points, you can see their exam points are also a lot lower compared to people, for example, people who got a full points in their exercise points. Their exam points are also very high, near the top. And contrary is true for people who got zero, who didn't do any exercise at all. But it's not absolute. There are also some people who got a relatively high points in the exam, even though they didn't do any exercise at all. Okay, to continue, we'll compute the mean and the standard deviation of exercise points over all observations, then compute the mean and standard deviation per grade. And this will be very simple. We just we can just print directly. So the first thing we want to print is the exercise points, the mean of the exercise points. And we want to format it to the last two decimal places because the calculation could that you don't know how many decimal points there are. So we'll keep the last two and we pass the exercise points mean. And we can see the mean of the exercise points is 10.11. And we also do the same for the standard deviation. We only need to change the function here. And we can see the standard deviation is 4.66. We calculate for the overall mean and standard deviation. And now we need to compute the mean and standard deviation per grade. So for each grade, grade 0, grade 1, grade 2, and so on. For this, we only need to create a for loop. And we want to iterate from grade 1 to grade 0 to grade 5. So we print, first we print the grade, exercise points, we wanted we wanted to match the grade that in the current loop. So for example, the first iteration, the first group, it will only match the grade in the variable grade that equals to 0. And we calculate the mean uh for this exercise points. And we also keep the last 2 decimal points. Then we do the same for standard deviation. It's the same code, you just change the function here. And then, yeah, you can see grade 0, the the mean the mean is 1.83, which is very low. And it grows according to the grade. Okay, that's for this task. And then the last step for this test is to, can you reliably tell if student is going to get grade 5 or grade 0 by looking at the amount of exercise by the exercise points? What would be the amount of exercise points that you could say the student will get a grade 5? And also do this for grade 4 and 5. You can check out the lecture notes and examples with fish that were discussed in the lecture. And oh, by the way, all the PowerPoints, all the slides for the lectures are uploaded on eLearn as well. So first, we want to examine if we can reliably tell if we can separate students from grade 1 to grade 0 by looking at their exercise points. So for classification, this time we will use another histogram. So we create a plot. First, we want to create people who got grade 0. Then we add another histogram to the plot, which will be adding people who got grade 5. Because here we want to see if we can classify student who got 0 and 5. Then we give it a title. And we show the plot. So again, the y-axis here are the exam point. Here are the x-axis are the exercise points, and people on the left are people who got grade 0, and this part here are people who got grade 5. So for the for the y-axis, we can see it's difficult to separate them. But for the x-axis, there's a very clear separation between the two grades. So people who got grade 0, none of them had an exercise points that's higher than 5.2, and people who got around 5.2. And people who got grade 5, none of them had an exercise points that's lower than maybe 13.5. So that's how we can separate those two based on the exercise points. What will be the amount of exercise points that you can say the student will get grade 5? Is here, it's somewhere around 13.5 or 14. Now, now we can repeat this exercise for grade 4 and 5. Let's just copy it here, and we change it to grade 4 and 5. And now you can see there are some overlap. We change the alpha, which is the transparency, to 0.5, so we can have a clearer view of how they are overlapping each other. Um, so for repeat this for grade 4 and 5. For people who got grade 4 and 5, we see there's an overlap here. So some people who got 17, they still got grade 4. And some people who had 14 points, but they still got grade 5. So for this, for grade 4 and 5, we can say we cannot reliably tell the difference to classify the two group of people. But for grade 0 and 5, it's very easy to classify them. Okay, that's it for the first task. And we will take a look at the second we'll take a look at the second exercise, the second task of this exercise. So given the normal data illustrated in the figure on the left, generate 10 circles using the negative selection algorithm. You're free to choose the size of the detectors. The lower and upper limits of the data are 0 and 1, respectively. Show your detectors in the same figure. So an example of the detectors is given in the figure on the right. The normal data is saved in this file. So so the figure on the right is what we want to achieve with our negative selection algorithm. First, let's take a look at the normal data. We can see the data are all float points. And here it says the lower and upper limits are from 0 to 1. Are from 0 to 1. So, and they are axis data. So x-axis and y-axis. And that's what we need to plot them. Like if we plot them, we will see something similar to this. Okay, to get started, we first import the data. The name of the data is normal data text, and we set the delimiter to comma, because let's see, here we have comma separates it. The data is comma separated. And then we need to transpose the data because the format of the data, we need to transpose it so the column will become the row. And it's easier to process them as access state as coordinate. Oh, I think my internet was interrupted. I think my internet was interrupted a bit. Okay, let's continue. We need to transpose the data to change the orientation of the data so the rows representing features to the to of the data points. So to transpose it, we just data and we will transpose. And then let's take a look at the data. You can see now it's much easier to plot them because this is the x-axis and this is the y-axis. Okay, now we've loaded the data. We need to define the radius of the detector, the detectors here. So we define a variable called detector radius, and we set it to 0.2. You can play around with these variables, these parameters. You can see how that affects your negative selection algorithms. And we also need to define the number of detectors. We set it to 10. And then we initialize an empty list to store the detectors that we will generate. Detectors. Is this? Okay. We've initialized this empty list. Then we will start a for loop to iterate the detector, to iterate until we find 10 detectors. So for I in range, in range of the number of detectors. So the for loop stops when we have found 10 detectors, and we need to set the parameter to find the detector. So we start an infinite loop while true that continues until we find a valid detector candidate. And we use NumPy to generate we need to generate random 2D points. So we set the size to 2, and there's a trailing comma because we need we wanted to generate one dimensional one we wanted to generate one-dimensional array that has two elements. So now the NumPy have generated a random points. We need to calculate if this random point fits our criteria. So we need to check the distance. And to calculate the distance, we want to calculate the Euclidean distance between the candidate detector and the data point in the data array. And to do this, we'll use the NumPy. We use the NumPy function. We subtract the candidate data from all the data points in the data array, which is what we loaded here. What we loaded here. And then we set the axis to 1. So here we calculated the Euclidean distance of all the data points that we have imported, and we subtracted the candidate data that were generated randomly here. And then we need to verify if this fits our criteria. So we use NumPy all and the distances that we got here, which was the result of the subtraction, we need to check all of them if they are greater than the detector radius or not. Because if it is greater, it means it's not near any data points that we have here. So if all the data points are greater than the detector radius, then we can append it to the candidates. We can append it to the candidate, and then we break the loop, the while loop, because we have found a valid candidate. Then it will append to the candidates, and it will loop until we have found all 10 detectors. And then we convert the detectors. We convert the detectors to a NumPy array so we can plot them easily. Okay, now we have the detectors and we have the data. We do a scatter plot for all of the data points. Here we are selecting all the rows in the first column. Here we're selecting all the rows in the first column, and here we are selecting the rows in the second column. And we can take a look at the scatter plot. Yeah, now we can see the plot is very, very similar to the ones we have here. That means we're doing it correctly. Now all we need to do is to add the circles, the detectors that we have found here to the plot here. So first we get the current axis, and then we loop through each detector location in the detector array. And we use plot circle. And the radius is the detector radius that and the radius is the detector radius that we have set before. And we can also set the color.
We cannot see your desktop.
Oh, sorry. I think it was interrupted again. The internet is not very stable. Can you see it now?
Yes, we can see.
Okay. So for here, we plot the circle and the parameters that we set are detectors that we need to add to the plot and also the radius that we have set before. And now we set the color to red. And we don't need to fill the circle. And now let's check at the plot again. And we can see we have all these detectors that are selecting data points that are not in the near the original data points. You can also play this around with different, if you want the detectors to be larger, and if you want to have more detectors, you can play it around to see different results and how negative selection algorithm works. Because we're using NumPy random function, each time that we run, it will give you different results. It's random. Okay, that's it for that. That's what you need to do for today's exercise. Um, do you have any questions that you want to ask or anything that you want to clarify? Okay, if you don't have any questions, if you do, you can always ask me anytime. You can ask me now, or you can send me an email later. Another thing is about the how we evaluate your exercises. So why do we give you points, and how do we why why would you why would we how would we give you points? And the goal here is to just to try. So as long as you have tried to do the exercise, try to implement these algorithms, you will get points. We're not evaluating you on the performance like or the accuracy of the results, how good your code is, um how accurate the result is, because I'm pretty sure anyone who wants to do this can generate this code in AI in 5 seconds to finish the exercise. But that's not the goal. The goal is to actually understand how how the algorithm works. For example, the negative selection algorithms, to understand how it works, how to implement them. So as long as you try it, we'll give you some points. And that's all that we need to cover today. Um, I'll also be posting some tips for the next week's exercise this as well. So if you have finished them by the time that we are explaining exercise two, you can also show other students the work that you've done. If you have tried this, if you have done the exercise beforehand and you want to show how you solve the exercises, then we can let you to do the to explain your code, how you solve the exercises. Again, does anyone have any questions regarding to the exercises or anything? If not, then that's all for today's session. Thanks to everyone who came to the session today, and I'll be uploading the recordings to the Moodle to the eLearn page later. Okay, thank you. Thanks everyone. Goodbye. Have a nice week.